Some farm machines weren't just hard to fix, they were nightmares. Packed with experimental systems, custom parts, and overcomplicated designs, a single breakdown could shut down an entire season. Dealers couldn't help, manuals didn't make sense, and spare parts nearly impossible to find. On paper, these machines were revolutionary. In the field, they were disasters. Farmers didn't hate them because they were weak. They hated them because once they broke, they were done. Today, we reveal 10 farming machines that were impossible to repair. Ambitious machines that proved innovation can go too far. Number 10. Ford TW Series. When the Ford TW Series tractors appeared at the end of the 1970s, they represented a major leap forward in power, size, and operator capability for Ford's agricultural lineup. These tractors were designed for large-scale farming, offering high horsepower, improved hydraulics, and more sophisticated control systems than earlier Ford models. However, the same technological progress that made them powerful also made certain versions notoriously difficult to repair. The core issue was Ford's early adoption of electronic control systems at a time when agricultural electronics were still in their infancy. Unlike later generations of tractor electronics, these systems lacked advanced self-diagnostics, standardized connectors, and robust environmental protection. When an electrical fault occurred, there was often no straightforward way to identify the source without extensive testing. Many dealerships themselves were still learning how to troubleshoot electronic systems, which meant downtime could stretch into weeks. Access compounded the problem. Wiring looms were tightly packaged within the cab and chassis, often routed through confined spaces to protect them from damage. While this reduced exposure to dirt and debris, it also made inspection and replacement extremely labor-intensive. A minor wiring fault could require partial cab disassembly, turning what should have been a simple repair into a major operation. Replacement parts were another challenge. Early electronic modules were expensive and not interchangeable with later systems. Once production ended, availability became limited, and repairs increasingly relied on specialist rebuilders or retrofits. Many owners eventually converted electronic components back to simpler mechanical controls to keep the tractors operational. Mechanically, the TW series was robust. Engines, drivetrains, and frames were not inherently unreliable. The repair difficulties stemmed almost entirely from the interaction between early electronics and traditional mechanical systems. Farmers who were accustomed to diagnosing problems with basic tools suddenly found themselves dependent on dealership expertise. The Ford TW series did not fail because of poor engineering. It failed to be easily repairable because it arrived too early in the electronic transition, before the industry had the knowledge, tools, and support systems required to service such machines efficiently. Number 9. International Harvester 2+2 Articulated Tractors. International Harvester's 2+2 tractors were among the most unconventional row crop machines ever placed into production. Introduced in the late 1970s, the 2+2 series used an articulated frame and a rear-mounted engine to improve traction and weight distribution. In the field, these tractors performed well. In the workshop, they became infamous. The articulation joint was central to the tractor's design and to its repair difficulties. This joint carried steering forces, driveline power, and hydraulic lines all in one compact assembly. Servicing any one of these systems often meant disturbing the others. Wherein the articulation components could cause alignment issues that required precise reassembly, something difficult to achieve outside a fully equipped shop. Engine placement further complicated repairs. By positioning the engine behind the cab, IH improved balance but severely restricted access. Tasks such as clutch work, driveline service, or cooling system repairs often required splitting the tractor or removing major structural components. Routine jobs that took hours on conventional tractors could take days on a 2+2. Hydraulic and electrical systems were densely packed, with limited clearance between components. Troubleshooting leaks or failures was time-consuming, and incorrect reassembly could introduce new problems. Because of the tractor's complexity, field repairs were rarely practical. The 2+2 tractors were not unreliable machines. When properly maintained, they were productive and durable. The issue was service complexity. They demanded specialized tools, experienced technicians, and significant downtime for repairs. Many farmers found that while the tractors worked well, ownership required a level of service support beyond what was practical for on-farm maintenance. The IH2+2 stands as a classic example of a design that solved one problem, traction, while unintentionally creating another, repairability. Number 8. Claas Early Lexion Combine Harvesters. The introduction of the Claas Lexion combine marked a turning point in harvesting technology. Early Lexion models delivered unprecedented throughput, automation, and efficiency, redefining expectations for large-scale grain harvesting. However, they also introduced a level of repair complexity that many operators were unprepared for. These machines relied heavily on integrated electronic systems to manage threshing, separation, cleaning, and engine performance. Sensors monitored nearly every function, feeding data into centralized control units. When everything worked correctly, the system optimized performance automatically. When something failed, identifying the root cause could be extremely difficult. Unlike traditional combines, where mechanical inspection often revealed the problem, early Lexion machines required diagnostic equipment and software. Independent mechanics and farmers had limited access to these tools, making dealer involvement almost mandatory. Even minor sensor failures could disable major systems, forcing downtime during critical harvest windows. Mechanical access was also challenging. To maximize efficiency and capacity, Claas packaged components tightly within the machine. Belts, bearings, and drive components were layered in ways that required removal of multiple assemblies to reach a single failed part. Repairs that once took hours could take days. Early documentation and training lagged behind the technology, compounding the issue. Many operators faced steep learning curves, not just in operation, but in maintenance and repair planning. Over time, Claas significantly improved service access, diagnostics, and reliability. But the earliest Lexion combines earned a reputation for being nearly impossible to repair without factory-level support, not because they were poorly built, but because they were too advanced for the service ecosystem of their era. Number 7. John Deere Early Hydrostatic Drive Tractors. John Deere's early adoption of hydrostatic transmissions represented a significant innovation in tractor operation. Hydrostatic drives offered infinitely variable speed control, smoother operation, and reduced operator fatigue, especially in loader and specialty applications. However, these benefits came at a substantial cost in repairability. Early hydrostatic systems relied on high-pressure hydraulic pumps and motors with extremely tight tolerances. Unlike mechanical gear transmissions, which could often tolerate wear and still function, hydrostatic units were far less forgiving. Minor contamination or wear could lead to performance loss or complete failure. Field repairs were virtually impossible. Hydrostatic units required clean room conditions, precision measurement, and specialized tools. In most cases, failures meant removing the entire transmission and replacing it as a unit rather than repairing individual components. This made repairs expensive and time-consuming. Diagnosis was another challenge. Symptoms such as power loss or overheating could originate from multiple internal issues, and without advanced testing equipment, identifying the exact cause was difficult. Even dealerships faced steep learning curves when these systems were first introduced. John Deere eventually refined hydrostatic designs, improving reliability and serviceability. But early versions left many farmers frustrated by repair costs and downtime. These tractors were not unreliable. They simply introduced technology that outpaced practical repair methods available at the time. Number 6. New Holland Early Self-Propelled Forage Harvesters. Early self-propelled forage harvesters from New Holland were a major productivity leap for silage operations. By integrating the engine, cutter head, feed rollers, blower, and drivetrain into a single self-contained machine, these harvesters dramatically reduced labor and increased output. However, that same integration made them notoriously difficult to repair. The primary challenge was component density. To keep the machines compact and balanced, major systems were stacked tightly together. Engines were often mounted deep within the frame, surrounded by driveline components, cooling systems, and shielding. Routine service tasks such as replacing belts, bearings, or hydraulic lines could require removing multiple panels and assemblies before the actual repair even began. Heat management further complicated repairs. Early forage harvesters generated enormous heat due to continuous high-load operation. Components such as bearings, seals, and hoses experienced accelerated wear. When failures occurred, technicians often faced cramped, hot, and poorly accessible spaces, increasing both labor time and error risk. The cutter head and feed systems were especially challenging. These components were central to machine performance, but buried deep inside the structure. Servicing knives, drums, or drive components often required partial disassembly of the front end. What might appear to be a straightforward mechanical issue could immobilize the machine for days. Timing made matters worse. Forage harvesters operate during extremely narrow seasonal windows. Any extended downtime during silage season had serious consequences, making repair difficulty more than just an inconvenience. Later, New Holland designs significantly improved service access, modularity, and cooling. But early self-propelled forage harvesters earned their reputation because they combined high mechanical stress with limited serviceability, making them some of the most frustrating farming machines to repair under real-world conditions. Number 5. Massey Ferguson, Early Electronic Draft Control Systems. Massey Ferguson was a pioneer in draft control technology, which automatically adjusted implement depth based on soil resistance. This innovation improved traction, fuel efficiency, and overall field performance. However, the early transition from mechanical to electronic draft control introduced significant repair challenges. Early electronic draft control systems relied on sensors, wiring, and control units that were highly sensitive to environmental conditions. Moisture, vibration, temperature changes, and electrical interference could all affect system reliability. When failures occurred, symptoms were often inconsistent, intermittent operation, erratic hitch movement, or complete loss of hydraulic control. Diagnosis was particularly difficult. Unlike mechanical linkages where wear or breakage was visible, electronic faults required testing equipment and system knowledge that many farms did not possess. Service manuals existed, but practical troubleshooting often depended on experienced technicians. Repair access was another issue. Sensors were frequently mounted in exposed or hard-to-reach locations within the rear linkage or hydraulic housing. Replacing or adjusting them often required partial disassembly of the hitch system. Control units were integrated into the tractor's hydraulic architecture, meaning failures could disable essential functions. Parts availability became a long-term concern. Early electronic components were not standardized and were often unique to specific models. As tractors aged, sourcing replacements became difficult and expensive. Many owners chose to bypass or disable electronic draft control entirely, reverting to manual operation to keep tractors functional. The technology itself was sound. The concept proved valuable and remains standard today. But early Massey Ferguson electronic draft control systems arrived before electronics were robust enough for harsh agricultural environments, making them notoriously difficult to repair and maintain in their original form. Number 4. Case IH Early Axial Flow Combines. The Case IH Axial Flow Combine was one of the most important harvesting innovations of the late 20th century. By replacing traditional threshing drums and straw walkers with a single longitudinal rotor, Case IH improved grain quality, reduced losses, and simplified crop flow. However, this revolutionary design also introduced major repair challenges in early models. The rotor system was central to performance and to service difficulty. Accessing the rotor, concaves, and internal wear components required extensive disassembly. Unlike conventional combines, where many components were externally accessible, axial flow machines concentrated critical parts deep inside the chassis. Early axial flow combines also placed high mechanical loads on fewer components. When failures occurred, they were often major rather than incremental. Bearings, drives, and internal liners experienced significant wear, and replacing them required skilled labor and significant downtime. Service documentation and operator familiarity lagged behind the innovation. Many mechanics trained on conventional combines were unprepared for the axial flow layout. Mistakes during reassembly could lead to vibration, imbalance, or reduced performance, compounding repair difficulty. Hydraulic and electronic systems further increased complexity. As automation increased, troubleshooting required a combination of mechanical knowledge and system understanding. For many operators, dealer service became essential rather than optional. Over time, Case IH refined access panels, modular components, and training programs. But early axial flow combines became known as machines that worked exceptionally well but demanded serious commitment when repairs were needed. Number 3. Deutz air-cooled tractors. Deutz air-cooled tractors earned legendary reputations for durability. By eliminating radiators, coolant, hoses, and water pumps, Deutz removed some of the most common failure points in agricultural engines. However, this reliability came at the expense of repair convenience. Air-cooled engines rely on precise airflow management. Cooling fins, shrouds, and ducting must be perfectly intact and clean. Accessing internal components often required removing extensive external shielding, turning even moderate repairs into lengthy procedures. Internal packaging was dense. Because airflow had to be carefully directed, components were tightly arranged, limiting access to injectors, valves, and internal assemblies. Heat buildup made working conditions uncomfortable, and tolerances were tight. Major repairs, while infrequent, were rarely quick. Engine teardown required careful reassembly to maintain proper cooling efficiency. Mistakes could lead to overheating and rapid damage. Deutz tractors rewarded longevity but punished service time. Mechanics respected them, but few enjoyed working on them. This combination earned Deutz air-cooled tractors a lasting reputation as machines that rarely needed repair, but were extremely difficult when they did. Number 2. Allis-Chalmers Power Director Tractor. Allis-Chalmers was widely respected for innovation, and the Power Director transmission was one of its most ambitious ideas. Introduced to allow on-the-go speed changes without stopping or clutching, the Power Director gave operators better control in the field, especially during heavy draft work and variable soil conditions. In theory, it was an elegant solution. In practice, it became one of the most infamous systems to repair. The Power Director was essentially a dual-range planetary transmission integrated into the tractor's driveline. It allowed operators to shift between high and low power ranges under load. This capability improved productivity, but it came at the cost of mechanical complexity. The system relied on clutches, planetary gear sets, and precise adjustment to function correctly. When properly adjusted and maintained, the Power Director worked well. The problem arose when wear developed. Slippage, harsh engagement, or loss of drive could result from relatively minor internal issues. Unfortunately, diagnosing the exact cause was difficult without disassembly, and repair access was extremely poor. Most Power Director repairs required splitting the tractor, a labor-intensive process that involved separating major sections of the machine. This was not a job that could be done quickly or easily on most farms. Even experienced mechanics often found the process time-consuming and physically demanding. Internal components were tightly integrated, meaning partial repairs were rarely possible. In many cases, multiple components had to be replaced simultaneously to ensure proper operation. Parts costs, labor time, and downtime added up quickly. Another challenge was adjustment sensitivity. Even after repair, correct setup was critical. Improper adjustment could lead to rapid wear or immediate failure, forcing repeated teardown. This made Power Director tractors unforgiving of inexperienced service work. The Power Director system was not poorly engineered. It was overly ambitious for the service environment of its time. Farmers expected transmissions to be repairable with basic tools. The Power Director demanded precision, experience, and facilities many operations simply did not have. As a result, these tractors earned a reputation as machines that worked well when everything was perfect, but became repair nightmares when anything went wrong. Number 1. Fendt Vario CVT. Tractors. At the top of this list stands the machine that permanently changed tractor design, the early Fendt Vario CVT tractors. When Fendt introduced the Vario continuously variable transmission in the 1990s, it was a breakthrough in efficiency, control, and operator comfort. It eliminated traditional gear steps, allowing seamless speed variation under load. In terms of performance, it was revolutionary. In terms of repairability, early versions were virtually impossible to repair outside factory-level service. The Vario transmission combined hydrostatic and mechanical power paths in a highly integrated system. Power flow was managed through precision hydraulic units, planetary gear sets, and electronic control systems. Everything operated within extremely tight tolerances. This design delivered outstanding efficiency, but left no room for error. Unlike conventional gearboxes, early Vario units were not designed for component-level field repair. If internal wear or damage occurred, the entire transmission often had to be replaced or rebuilt at specialized facilities. Field diagnosis was limited, and even dealer technicians required extensive training and proprietary tools. Electronics added another layer of complexity. The transmission relied on sensors, control units, and software to manage power flow. Early diagnostic systems were far less user-friendly than modern equivalents. Faults could disable the tractor entirely, even if the mechanical components were still intact. Access made matters worse. The Vario unit was deeply integrated into the tractor's structure. Removing it required major disassembly, specialized lifting equipment, and precise reinstallation procedures. This placed repairs far beyond the capabilities of most farms and independent workshops. Early Vario tractors were not unreliable. In fact, many ran thousands of hours without issue. But when failures occurred, owners faced high repair costs, long downtime, and dependence on factory-authorized service centers. Over time, Fendt dramatically improved reliability, diagnostics, and service procedures. Modern Vario systems are far more maintainable, but the first generations earned their reputation honestly. Unmatched performance, paired with repair complexity that redefined what serviceable meant in agriculture. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.